to provide the best solution for mill-turn machine, and also the easiest to use. It's not only a matter of supporting the functionality, but we want to do it in an easy way. And in the last year, I mean 1 year, last calendar year, we have been doing most of our effort advancing this subject of mill-turn in SolidCAM 2016, led by Michael Vinetsky, our mill-turn product manager, very experienced in handling all these types of machine, and he worked very closely with our developers and with our other people from our resellers and branches who want this functionality. So it was really a joint effort of all, and I think the results are very exciting. Obviously, I just want to go very quickly into a few things that you'll see today in the next webinar. First of all, the subject of better definition in the VMID of the machine, where the approach now is the device is on the axis and not the axis on the device. So we can support several devices mounted on the same axis. And this makes the definition also similar to the machine simulation representation of the machine. Another major advance is this preview that you will see during the presentation all the time, because we want you to know at every point how does the machine look like, how does the tool look like, where are the axes. So you'll really enjoy seeing what we have done in this subject of machine preview. Another important subject was knowing exactly at every point where is the stock. So the stock is mounted on the table. We know where is the initial stock, and at every stage of the machining, we know where is the stock. So this is something also an important advance in SolidCAM 2016. And as I said, also tracking the stock position in the machine. We have new clamp options. They'll show you in the demonstration. Also, for the MCO, it was important for us to show you interactive machine preview so that you could really define your MCO well and see what is every step you define the MCO, you can see the machine preview. Also, another important improvement is any action by the CNC operator can also, manual action by CNC operator can be also defined as an MCO. And this way, it can be taken into account when we calculate the machining time and when the operator does a manual stock transfer from table to table. There is also improvement in spin definition. Florian will talk about it. Also very important, we show you an interactive machine preview for the tool table. So you see how the tools are located in position if they do any maybe possible crash with the body of the machine. So this is also an important improvement. Basically, we want you, this is what I said, ease of use, to see at every stage how does the machine look like, how does the tool look in the machine. So this is also obviously the subject of synchronization. This will be a subject of a special webinar in some time. So the end result, I mean, of all this effort is we provide you extended support of complex mill-turn machine in an easy way. And even the support for the not so complex mill-turn machine, I mean the standard one with two spindles, now it's much easier to program them and support. So this is really, SolidCAM 2016 is a milestone in SolidCAM history because, you know, we had integration with SolidWorks. This was a great milestone. We had iMachining. It was a great milestone. And support for mill-turn now is another major milestone. And I'm sure all your customers will enjoy it. Okay, Florian, go ahead.
Thank you, Emil. Before Florin will start, I would like to remind you that this is an online webinar, so you can ask all questions you have. You have a webinar panel on your screen, and you have a chat window there. So just type any question you have, don't hesitate, or just chat us that you would like to ask the question online, and we will open the line at the end of the webinar. So enjoy the webinar, ask all questions you have, and Florin, you are unmuted now, and you are presenter.
Thank you, Eddie, and thank you, Emil, who already present our subjects today. I will start sharing my screen. And first of all, hello everyone, and I'm very proud to be the one who present this powerful version of SolidCAM 2016. As Emil says, behind us, the presenter, there is a great development team who work very hard to bring us all these changes and improvements. I will start in this webinar. This is only the part one, and we'll continue next week, step by step, to show you all these improvements by doing a part and seeing how exactly how we use these new developments and improvements. So I choose a simple part, and we will work on a standard machine that we support also in previous versions. But it's important to see the difference in handling the part and defining the technology between the previous versions and the present version. So we will start defining a new mill turn. And we'll create coordinate system, we'll define the stock, standard procedure, but already here in this step you will see a change. In the previous versions on a machine with 2 turrets and 2 tables, it's a DMG Morisaki NTX 2000. So we have 4 sub-machines. In the previous versions, we define 4 coordinate systems. This process was done automatically by settings that we have in CAM settings. But anyway, in the past, we need 4 coordinate systems for each sub-machine. So you have here on the face of the part a 2 coordinate system, 1 for upper turret, 1 for lower turret, and also on the back side of the part 2 more coordinate system for the back spindle, upper turret on back spindle, lower turret on back spindle. Now, today we can use only 1. This is a new big improvement. You can still work as in the past with many coordinate systems as you need, but it's not a must. So you can work with only 1, and many users ask to do this. Now, another reason is creating an operation on a specific sub-machine. For example, I work with the upper turret main spindle, and defining the geometry, defining the tool. If I change my mind, I want to change the technology and move this operation to the lower turret or to back spindle, I lose everything, all the information. I have a new coordinate system. I need to create a new geometry, extensions, links, all this I need to define from start. Today, we can work with the same coordinate system, we lose nothing. We just change the tool, the sub-machine and the tool, and that's all. operation move to another submachine. I will demonstrate you this now. But for now, let's start defining the stock. It's a cylinder relative, and let's give them 2 millimeters and 10 here, and 2 millimeters again. Generate envelope. All this can be done automatically by CAM settings, but I always want to be in control of what I'm doing. Step by step, this is the target. That's a way of work also. And now we have the part defined. The next step is to start defining the setup and creating the operation. But before that, Emil already showed you in the presentation the improvements in VMID. Let's see, I will open the VMID. This is my machine. And here you can already see the change in the structure, similar to machine simulation, and also this structure giving us more options to define complex mill-turn machines with more turrets who share the axis. And we have a lot of examples of machine with 2 turrets, one type spindle, second turret type linear, sharing the same axis. In the past, we will need to define twice for each turret, again, the same axis and with the same properties for each axis. It was not an easy way. Today, it's more simple and more faster. Now, you will see also options like drive unit. We can define a lot gears for each spin unit. We have the drive unit, spinning unit, the engine who rotates our tool, milling tool, live tool. We can define the gears, and also for each station we can define how this station receive this spinning unit. A direct, a gear, self-drive, and we have a lot of examples, or not drive, and then from this station maybe I don't have this option of a live tooling. So many options that we didn't have in the past, we have now. We can define exactly the machine and how it is real. Other options, there are so many parameters that we can define today in for each submachine, because things like compensation, arcs, or 5-axis options, properties, that we can define for each submachine a different type of property, program numbers, procedures. Many improvements in this VMID. But this is more for the support guys who define the machine. They have more power, not exactly for the end user, but for any user that he wants to learn, and he opened the VMID, he can see here the improvements. So let's go and start defining the setup for this part. I will create a machine setup. Here again, we have a new change. In the past, you have 4 submachines, each submachine with a home assignment Each we have Mark 1 coordinate system for upper turret main spindle, coordinate system for turret back spindle, lower turret main spindle, and back spindle. For some machines, for this machine, today we need only 2, because we start to define a new way, a new approach to mount this part on the machine. We mount the part on the table now. The part is not mounted on some machine. The part is mounted on table. So even if I work with upper or lower turret, the part is on main spindle. I don't need to define twice shift, X, Y, Z, and twice the same fixture. Its main spindle is the same device. So today we mount the part on tables, on main spindle or back spindle we have here. Of course, we can have machines with 3 tables, 1, 2, 3, maybe more. And the new option to control the stock, the presence of stock, where I start to work on this part, on main spindle, on back spindle. In the past, we use some logic to guess or to know where is the part. Now, today we know exactly where is the stock, because we define in setup, and after that, in the machine control operation, we control it and we move the stock from one spindle to another with the transfer process, with automatically transfer process, and sometimes the user take the part in the hands and move it to the other spindle. So we have also the option that you already see, and we'll show you in the presentation, CNC operator with some actions. It can do a manual transfer. We can also support this. But all the time we are in control and we know where is the part. So we have a main spindle, and let's create a fixture. The standard fixture, we'll take it from the library. And this is clamp. And here for the back spindle, we create another one from the library. We call it clamp 1. But for the back spindle is mirrored. For the back spindle is not important the position, because the position where I will catch the part is controlled by MCO. MCO, I will command the W axis, the back spindle axis, to come and catch the part. So it's not important where I position now, axial position NZ. I can catch it here or here, is not so important. When is important? When the user use manual transfer and he take the part manually and transfer it to the other spindle. Then we take the information from here. In any other case, with transfer with the MCO, we take the information from the MCO. So I will create an MCO. I don't care about this position now, but I want to catch the part. The clamping diameter is important, because I want to see the jaws exactly on the diameter where I want to catch the part. And as you can see here, we have those sharp edges, but I don't want to catch it here. I will rotate the spindle, I will rotate the back spindle and the jaws to catch the part on this hexagon on the surfaces. So this surface is somewhere like 20 millimeter diameter. Okay. Let's also generate the fixture envelope for the first one, and for the back spindle envelope, we have the envelope, and now we can select the position to position the fixture and the party on the spindle, so on the table. So here, with this edge, will be mounted on the face of the spindle, the main spindle, and pick Z. This edge will be mounted on the face of the back spindle. I can see the red dot point, the center of the main spindle, and this red dot point, center of the back spindle. Well, the setup is ready. I know where is the stock, is on main spindle. I can start to create operations. Let's hide this, we don't need it. Before the operations, I will import some tools that I defined before. No, I don't work in inch. I will select, yeah, this is my tool table, import all. Okay. Now we have the tool picture as in previous versions, but in the mounting, this is our surprise here. We can see the entire machine with all the tools mounted that I import here. We have tools on upper turret and we have tools on lower turret. Now I can browse and bring the tools in the working position. Now the tool number 1 in the station number 1 is in the working position, but if I'm going and select the tool number 5, which is station number 2, it will be in working position. I can check if it's mounted correct. I can check if I have any collision with surrounding tools or maybe with the machine covers. I can rotate the turret, rotary turret axis, and see if there is any collision, because it happens when the tool is too long and I rotate the turret, I change the tool, sometimes the tool can touch and have a collision with machine covers. Not in our case here, the tools are in the correct dimensions. So not only the tools for lower turret. Now let's see on upper turret. I have tools on upper turret. I can also browse them. On any click on the tool, it will be mounted on the upper turret. This tool number 1 is a 80 degrees insert. Now the tool number 2 is 55 degrees insert, 35 degrees insert, and I have a milling, 10 millimeters milling tool, and 5.1 millimeters drill tools that I will use in this part. Very easy to see and very easy to mount these tools. We use the same process, holder, a steel holder we defined before, but today you can see exactly how they will be mounted exactly on the machine. More than that, I can control the axis. Each axis that I have on the machine, I have them here. Z2 is the Z-axis of a lower turret. I can move it, and W, the axis of back spindle, and when I reach the limit, the device becomes red. I reach the limit. Z1 is axis Z of upper turret. X also collisions detected, limits, X2, C, Y, and B, of course. All axis in control. So this is about the tool. It's very easy today to mount the tool. It was a very hard work to do and to bring us all these improvements. We can show and hide the machine STLs. We use the STLs, the models from the machine simulation. We don't need to define them again in any other process. We have the machine simulation. We just use them from there. We can hide all the tools and focus on a specific tool that I click on it. Many options. Okay, so I have the tools. Save and exit. I will start defining an operation, a turning operation on the main spindle. And here, it's nothing changed here. We continue to define the operation based on submachines, but using one coordinate system, it will be very easy to change, to take this operation and move to another submachine. So I have the contour. I'm going to modify the geometry extension up to the stroke and select the tool. I don't know what is this tool. Let's check. Okay, this is a tool that I can use for roughing. 80 degrees insert on upper turret. I will select working on 0 degrees, additional angle, disposition, levels, technology. I work on face. Save and calculate. I already have the tool path. And save and copy. I want to use the same tool for a long turning process. Just change the geometry from here and let's say up to here. Remove all material. Modify and 2 more millimeters. The same tool, the same orientation. And now we will work long when I don't define any finish because I want to create the finish operation with other tool. This is a tool which I use only for roughing. So here I have the toolpath for long turning. Now let's simulate and also let's see the machine and see how it's working. Of course, we can use HostCAD and Solid Verify. Let's see the machine. This is the machine, the DMG Morrisei NTX 2000. Let's check again something about the clamp. Okay, the clamp is correct. It appears to me that something was incorrect on the fixture. Yeah, seems that the fixture is in the wrong position somehow. Edit. Okay. calculate again. Anyway, it's a new version, and it's still not released in the development stage, so some bugs can be existing. And let's try to simulate again. No. The picture is still created in the wrong place. That's happened to me a few times, but it's not a bug that I can catch very easy. I will define two more operations and it will be fixed. So we have the roughing operation on face and long. Now I will define the finish operation, turning operation. I will select the first one. I use the same geometry and I will just change the tool. Select tool number 2, which is a 55 degrees insert. Okay. Level technology finish only. And another operation for, excuse me, turning. I will select the second operation, then change the tool for this contour, for this geometry. Select tool number 2. In this position, and in technology I will select finish only. Save and calculate, and let's see. Okay, I have the finished toolpath. Now, after I define the operation, I change my mind for any reason, and I say I want the finish operation to be done by lower turret. I don't. Upper turret can do something else in the same time, can work maybe on a bike spindle, or can work on upper turret doing something else, or maybe I don't have enough tools in the magazine for upper turret, and all my turning tools are on lower turret. So I want to change for these two operations, for example, I want to change the submachine, to move them to be done on lower turret. So as I said before, changing from upper main to lower main, automatically in the past we change our coordinate system, and our geometry we need to define again, because this geometry is assigned to a coordinate system. I change the coordinate system and I need a new geometry for this coordinate system. Today, not. I will work with the same coordinate system, Mark 1, position 1. I just move to lower main and select another tool for this turret. So I'm going to the turret, see the mounting, and I think tool number 5 in station number 2 is the 55 degrees tool. Yes, that's correct. That I need. So I select the tool, save and calculate, and the job is done by lower turret main. Very simple. Technologies, geometry, modify, extensions, all this and links are saved. Nothing changed. I just select the new submachine and a new tool. That's all that we need to do. Let's do it also for the second finish operation. I will change it to lower main and selecting a tool from lower turret. Save and calculate, and now the operation is done by a lower turret on main spindle. I want to check again. Clamp edit. Something here. Maybe. And the diameter is okay. Let's move to here, for example, and to create the envelope again. And let's select the Z position. So this is my envelope. That should be. I need to see this correctly in machine simulations. Calculate all. All this system is new. We work today for anyone who asks. We work on Windows 10. That's with SolidWorks 2016. The new version is already Service Pack 0.1. We have updated, and SolidCAM 2016. All the system is new. It's barely. I work only maybe a week on it. So many things can be happened. Windows is new. SolidWorks is new. Also, our SolidCAM is very new. Let's try again. Okay, finally. Something in the setup. Now the fixture, the jaws are defined correctly. So this is the machine. Zoom. And I will hide the machine just to see only the device. Turning operation on face, rough, long, and I'm going manually here with the mouse wheel. Now lower turret with the finishing operations. Okay, I will hide this geometry. Now I will define a milling operation to mill this contour here, the hexagon. Milling profile with the upper turret, upper main. The geometry is constant Z, and the tool is a 10 millimeters tool. Mounting always easier to use mounting and see the tool. Okay, this is the tool, 10 millimeters milling. Levels. I will start from here up to here. And the technology, link 45 degrees. Save and calculate. Let's see. I have the geometry. Now, I have a reason to do this now. I want to show you something. You already know that, but let's simulate again. I'm going to machine simulation. I want to show you. Sorry about that. After working with lower turret, now I will jump directly to my last operation. After working with lower turret, I didn't send the lower turret to a safe position. This is the end point. Here the job was finished, the operation was finished, and the lower turret stopped here in this position. Now if I come with upper turret, start working on the part, of course I will have a collision here. So we need to use the MCO, machine control, to move and to retract the lower turret. Now, how we create the MCO today? Much easier than in the past. Add a machine control and lower turret. Show machine preview. Here in machine control, in operation, in tool table, have the same window. It's a standard today. This window, we can use it in every part. So here I define this machine control operation after last turning operation. So after last turning operation with lower turret, and this is my position here. Also the upper turret and also the lower turret. This is the last position. Now I'm going to do a movement, but I'm not using, as in the past, the user need to know what values to put in each field for each axis. You need to understand the machine and to put here the values. Today, no, I'm going to move x-axis manually with mouse wheel, go down, do a retract. Oh, that's the limit. Great. So I'm on 0, and now I will move with the mouse wheel in Z direction. That's enough here, this position. It's safe for me. The tool have no collision with the spindle. Everything is okay. Dimension is not important to be something precise, 750 or any other number. I just want to bring the turret to a safe position. And now, pressing on this button, I will paste axis values to the MCO. So, in X, go to the reference, to 0. In Z, go to 730 millimeters point. Well, I can... But what I want to do is to separate the movements. I want first to retract in X, after that to retract in Z. So I will take this value from here up to here, minus 730. So this is my retract today. This is the way that I create an MCO. I move the device in the machine preview, have all the axes in control, take the values in my program, and that's all. Save and calculate. And now if I simulate again, you will see a retraction and working with upper turret very in a safe mode without any collision. Now, let's transfer this part to the back spindle. Again, I will add a machine control. Now, the last operation was working with upper turret on the main spindle, so I will send the upper turret to a safe position. First, the rotation of the milling tool is stopped. If I have a coolant before activated, I will stop the coolant and the movement. Again, I will use the machine preview. So B-axis is already in a good position, minus 90 degrees. I'm just sending the X using control with steps of 100. I'm sending it to 0. And maybe a little bit in the Z-axis. That's enough. And paste the values here on this line. Again, this is 0, and minus 450. We said 650. That's enough. And paste the values. Now, 90 degrees on B is not needed because the axis is already on 90 degrees. And first I want to do X. After that, Y to 0 and Z to minus 650. Those are the movements. So upper turret is retracted. And I can start working to prepare the spindles because they need a preparation. Main spindle is, after a milling operation, it is already in a milling mode. The C-axis is connected, so I just need to move the C-axis to 0. And pay attention what happened here. The part is on main spindle. We know that. So if I select, if the user will select the movement, I want to move the C-axis. Pay attention about the color is a little bit, it's like disabled. I cannot do the movement here because I cannot move the C-axis without the part. The part is sketched by the jaws on this spindle. I cannot move the C-axis and part not to be moved. So this option is not a correct one. So I'm going to do the part move. I will rotate the C-axis and the part will rotate together. We know from the setup that the part is connected for now up to this stage on the main spindle. Okay, so the main spindle with C-axis on 0. Now the back spindle. On the back spindle, I don't know about his working mode, so I will activate the milling mode, C-axis connected, and here I can use the movement. On back spindle I have no part, I can move only the device. C-axis to 0, and here I will use the machine preview. I want to move W-axis, why I don't see update machine, I don't see the fixtures. Something's going on here. Don't see the fixtures on the back spindle. I need to see the fixtures, guys. We need to check again the setup. Something was wrong with the setup from the start, also in machine simulation. So for now, let's define it and check after that. And go to, only a problem of refresh. Now we see the fixture. Surprise, surprise. And come with the rapid move up to this position, let's say 1,375 millimeters with the rapid. And here, I say that before at the start, I don't want to catch the part on this sharp edge. I want to catch the part on the surface. So I need to rotate the C-axis 30 degrees. Everything is in my control here, and you can see exactly what you want to do. 30 degrees on the C-axis. Paste these values. And from here, I will go with feed and catch the part. Okay, rotate, zoom in. That's a good position. Delete and delete with 100 millimeters. Now, from here, I will use a clamping. I will clamp the part close on stock. Now, the close on stock tell us that the part is controlled now by the back spindle. Is no more controlled by the main spindle, but by the back spindle. Close on stock, I will catch the stock with the back spindle. Is in the control of the back spindle. It's like in the setup, when I define it in the start, stock is on main spindle. Now close on stock tells us stock and the part is on the back spindle now. Main spindle clamp open and back spindle again, part move, go to home reference. Save and calculate. And let's try to simulate. Okay, I will jump to last turning operation. After the turning operation, I have a machine control lower turret retract and milling with upper turret and retract. I start the transfer process. Upper turret retract to a safe position. Lower turret is already in a safe position. Back spindle entering in the milling mode. C-axis to 0. And W with rapid to this position. Catch the part exactly where I want to catch the part on the surface. Taking the part, unclamping on the main spindle and taking the part to the reference. Here we can continue to work now and define a very fast 2 operations and the turning operation. Only one, it's enough. And lower back. Lower back. I will work with lower turret on back spindle and select the geometry from here and up to here is enough because I already see the material, the rest material. Modify geometry, extension, no need to do extensions. And the tool, now we'll select the tool to work on the back spindle. Which tool should I select? I want an 80 degrees insert, which is here. Let's rotate a little bit. Start. Okay. This tool, working on the back spindle, is an 80 degrees roughing tool on station 4. Okay, so tool number 7 is on station 4. I bring it up. That's my tool. Technology, long, rough, save and calculate. And save and exit, save and copy. Select the finish tool. The next tool should be a 55 degrees insert. Yeah, that's correct. Which I use for the finish. And in technology, finish only. Let's create here a drilling operation. For this, we will create a position at the milling, drilling, coordinate system. Okay. And define the geometry. Selecting the tool, which is already defined on upper turret. Levels. The level here, I will start from here, 6.5. And drill depth here. That's 15. Delta -1 millimeter and full diameter. Stock is absent on this machine. I did this mistake by mistake. They didn't intend to do this mistake, but that's very good that I did it. In the start, I select the wrong submachine, upper turret on main spindle, but the stock is already on back spindle. So when I save and calculate, first of all, when you put the mouse, bring the mouse on the operation, you can see the red dot, red point. Stock is absent on the selected submachine table. The message is clear. I didn't select the correct submachine. My part is on back spindle and I select to work on upper turret main spindle. Change it to upper turret back spindle and that's all. Save and calculate. Very simple. Nothing wrong in the operation. The coordinate system is correct. The geometry, the tool, everything is okay. Just select the correct submachine. This can happen to each one of us, but to find an easy way to fix the mistake, that's smart. So let's simulate the entire part. And you can start asking me questions. Sydney, you can read when the time that I simulate the part. If we have any questions, you can read them and I will answer. Sydney, are you with us?
Yeah, Florin, thank you very much for.
Sorry.
Yeah.
Okay. So.
Thank you very much, Florin. It was a very interesting first part of webinar of the Milton series, and we have first of all many remarks about how important and how good are these innovations. So first of all, thank you for your positive feedback, guys. And in any case, we have few questions here. So first question is, will machine preview also work on defined cycle in MCO?
Of course. When we define cycle, the cycle is defined in a manual mode. We define each movement with the machine preview. First of all, when we define the cycle, it's only saved as a cycle, but all the actions that we do in a cycle, there are standard actions that we can do manually in MCO. So yes, machine preview is simulated and it can be used in the cycles.
Mm-hmm. Okay. One more question. Should be the catch position in MCO with the same value as it is already defined in the setup because of correct transfer and G-code?
That depends on the MCO. That's not dependent on the setup. The value that we define in the setup is used only when the user selects to do a manual transfer. So if here I will create an MCO, CMC operate and use the manual stock transfer, then we will take the setup position of a fixture on the part. Only in this case. Any other case, I will take the position that I define in MCO. I bring the W axis to some position, and that's where I catch the part. It's not where I define in the setup. It's where I bring the W axis. That's who define the catch position.
Okay, guys, so if you have more questions, please prepare your questions for the next webinar, and we will put the recording of this webinar on our website. So thank you very much, Florin. Very interesting webinar, very good explanation and clarification.
I enjoy to present it.
Have all of you, please have a nice weekend, and we'll be in touch next week. Good luck with the end of the year sales. Thank you.
Bye-bye.